Hi, Trevor. We'll get started here in a couple of minutes. Let's give a few moments for other folk to get here. Thanks for your patience. Trevor, thanks for your patience. Let's give one more minute and then we'll go ahead and get started. All right, I see we have a few more folk that have joined in, so we're going to go ahead and get started. Thanks for your patience while we waited for folk to have a chance to get in here. Let me go ahead and share my screen. Okay, is everybody seeing the course homepage okay? Somebody, please let me know.
Yes, ma'am.
Thank you very much. All right. So, as with always, our sessions are being recorded and I will be posting the video in the announcements as I have been for all of the other prior class sessions. It'll take me a couple of days, so bear with me while I get it captioned. Also, while I have you here, I'd like to go ahead and make the announcement that Thursday we will not be meeting. Okay, I'm going to cover everything we need to cover today. Of course, I will be available for questions. You can shoot me an email. I'm going to be attending a conference in Atlanta on Thursday. And so, we won't be able to meet then. But, we can take care of everything we need to take care of today. And I'll address any questions you have. Okay. And I will be checking my emails periodically. So that way, if you have a question, don't hesitate to reach out to me. All right, so in keeping with what we're covering in lecture, we're going to be looking at an experiment dealing with uniform circular motion. In lecture this morning, I described some basics regarding uniform circular motion, in particular the speed and acceleration formulas. And what we're going to be doing here is looking at an example of orbit motion. And you're going to utilize that orbit motion to help you, get a better grasp on the properties that we deal with in describing uniform circular motion. Okay, so these are the activities that you have on your plate. So we'll take a look at the experiment handout. We'll talk about the post lab and the lab report that are all due by Saturday. And for those of you who might need to, to review some materials because maybe you took the lecture at a different point, or maybe you have someone different as your instructor. If you want to kind of, review concepts regarding uniform circular motion, you have access to the chapter in the textbook that covers that. That's the textbook that we use for lecture, the CK12 textbook. And I bookmarked some videos for you there. I do believe those are right out of Khan Academy as usual. So you can go take a look at those if you need to, kind of refresh and review that topic area. Okay. And for those of you in lecture, we are going to meet Thursday because I want to have time to work some sample problems. So I'm just going to find a quiet corner at the conference and Zoom in with you guys for lecture, but we'll be done with lab today. Okay. So is everybody clear on that? Any questions about that? Oh, I apologize. I didn't start my video. Okay. All right. So let's take a look at the actual experiment that you're going to be doing. And remember, the whole idea here is that this handout is a guide. It guides you through the process of completing the experiment. After you've done the experiment, then we'll take a look and see what you put in the lab report. And finally, we'll talk about the discussion that you have to complete, right? So you can see here, all of the objectives relate to you being, helping you to become more knowledgeable about uniform circular motion. We're going to use this simulator as our example. Now, I do apologize. I've got to have time. I just have not had time. It says here, click the big red 5. But you don't need to worry about that. Just hit the play button. They've gone back and revamped these things since I created that handout, maybe a couple of semesters back. Just hit the play button and, it'll open up the simulation. Okay. And we do the model setting. That part of the handout, where it says use the model setting is correct. It's just they have a play button now instead of the big red 5. And hopefully here sometime before the next semester starts, I'll have a chance to go in and update the document. So I do apologize that, that big red 5 stuff is still there, but hit the play button, you'll be okay. All right. So, turn on all the bells and whistles, if you will, meaning, click all those. You have a choice of what scenario you want to use, and the moon going around the earth, the satellite going around the earth. You can even look at the earth, moon, and sun system. I typically like the satellite motion. That's something that I focus on a lot in our lecture class. And so once you have all those items on, it's just to hit the play button. Okay. And you can adjust the, the orbit distance, if you will, by, dropping and dragging the object closer to or further away, however you like to do it. Okay. And you play around with that and you see, bam. Okay. That's not going to work. All right. So, you can just reset it and move it out a little bit and see what happens there. Play around with the various settings is the whole idea. Okay. Now, one thing I will tell you is on this simulator, they use the blue arrow to represent the gravity force. We are using the blue arrow to represent centripetal acceleration. Okay. We are not dealing with force here at all. We are dealing with centripetal acceleration, and the blue arrow shows you the centripetal acceleration of the object that's in orbit. We want to focus on the object that's in orbit, okay? So if I change that, for example, to the Earth and the sun, you can see the blue arrow dealing with the Earth, the object that is orbiting. That is the one we're focused on, okay? All right. Any questions on how this simulator works? Oh, by the way, you can also adjust the mass, those kinds of things. If you wanted to, you could play around with that. Like you can pretend we got a big Earth or, Again, play around with it. The whole idea is for you to get comfortable with, as I change these various things, what happens to the motion or the velocity or the acceleration, okay? Any questions on how the simulator works? Okay, so you are going to use this simulator to answer these questions, okay? Those are your questions. All right. And I will tell you that this calculation question that's here, you will have to utilize the the uniform circular motion formulas, and you can find those formulas in the chapter or the videos, the readings and viewings material, okay? For those of you who don't have me for lecture, that's where you can find those formulas, all right? So any questions on the experiment that you have to conduct? Go out to the website, play around with it, use it to help you answer these questions. Now that's just the experiment part. The lab report, notice it says here, oh, I'm sorry, I hit the wrong button there. Let me go back. Come on, don't play around with me there. Hold up. Okay, so what goes in the lab report? I should have hit that button. Notice, this is the format for the lab report, okay? Some of you are sending me the abstract and conclusion and no experiment handout. Some of you are sending me the experiment handout with no abstract and conclusion. A lab report, a formal lab report, requires all of these things.
I have a question about the abstract. Do you want us to talk about the experiment itself, or do you want us to like try and refer to a real life situation?
No, the abstract is about the experiment you perform. Okay. That's why it says explain the procedure that you followed. That procedure comes from the experiment. Okay. What you did, and then how you did it. So that's why I give you guidance right there, right? How you did it. Give me the URL that you use, right? I use the simulator at whatever website to perform this experiment. That way, somebody who's trying to repeat your experiment can look at your abstract and they know what procedure to follow. They know what simulator to use. They know, they understand something about what you found when you used it, right? And they understand why you did all of that stuff, right? So the abstract is you giving details about what you did, how you did it, why you did it, and what you figured out while you were doing it, okay? Now remember, under what you found, this is not about your data. Under what you found, in this particular case, it says what? Discuss something that you figured out about how the values in your data change as you manipulate the simulator. So, what happens as you make the Earth bigger or move the satellite further away or closer up or, change the size of the moon, or something that you figured out that, is related to, how you manipulated the simulator, how things change as you adjusted figures on a simulator. But I'm not asking you for specific data. I'm just asking you for in general. Okay, you could think of it this way. Under what you found, when you're using the simulator, I'm asking you, what patterns did you see? Okay. And then the data is the completed experiment handout. Well, in this case, it's the questions that you had to do, right? Those are the questions from the experiment handout that you have to answer. And then conclusion, tell me something that you learned. Tell me something about uniform circular motion that you learned as a result of doing this experiment. See, what you found tells me something, a pattern that you figured out as you use the simulator. What you learned is overall something you learned about uniform circular motion or about the topic of the experiment, right? Okay. Do you understand the difference between the two? Because some people are mixing up what you found with the conclusion.
what was the conclusion supposed to be about percent error?
No, you aren't making any measurements here. So how are you going to do percent error? The conclusion is always about what you learned. Under what you found in the abstract, if you had made measurements, then you could talk about percent error. But it tells you clearly here for the lab report format, when you use a simulator, you're telling me something that you figured out about how things change as you adjust things in the simulator.
Okay.
Yeah. Yeah, you have to have measurements to do percent error, and you don't have that in this case. Okay. Anybody else? Questions on what specifically goes in the lab report? These are good questions that you're asking, by the way, because these are kinds of common mistakes that people make. When they write me a lab report and say, I got percent error values between 10 and 50%, and they didn't, how'd you get that if you're using a simulator? What'd you measure? Okay. All right. So that's the lab report that you have to do. And then, as always, after you've done the experiment, after you've done the lab report, then you want to complete the discussion. The discussion requires that you answer these 5 questions. And then you come back and you engage in a conversation with your class, at least 2 of your classmates. Okay. Those items are due by Saturday. And then, of course, there's instructions on how you submit the lab report. And then the class questions forum is your space to have, dialogue with your classmates about anything that you want to ask up and talk with them about regarding the course. What questions do you have about this week's overview? All right, so I'm going to stop the share. If you have questions, feel free to hang around. If not, we're all done. Remember, we won't meet on Thursday, and I'll post an announcement reminding you, and I'll post also this recording for you as soon as I get it captioned.